All right, so we are on 9-1, day 2. We left off with problem 3. So find this problem in your notes. Might want to do split screen and kind of follow along. So we have a couple quadratic functions here. We got 3 actually. And we want to compare the widths of these. So what I'm going to do is I'm just going to highlight this one in orange. Go down here and highlight this box in orange. I'm going to set up an XY table. Second one, I'll just do that one in green. So I'll highlight this one in green down here. And then this next one, I'll do this one in purple. Okay, so I got purple right there. And I'll write it like that. Okay, in order to graph these, we've got to have some points to graph. So we can just make a table here. This is y equals negative 4x squared. I'll make x and y right there. I'll just pick 0, 1, and 2. We don't need that many points because we can reflect them and get some other points. So when I plug in 0 right here. 0 squared is 0 times negative 4 is 0. When I plug in 1 right there, 1 squared is 1. 1 times negative 4 is going to be negative 4. When I plug in 2, 2 squared is 4. 4 times negative 4 is going to be negative 16. Okay, so I'm going to go over here and plot these points. I have 0, 0. I have 1, negative 4. And I have 0, negative 16. We can just kind of estimate where that would be. So 2, negative 16 might be right around here somewhere. Okay, and then what I can do is I can graph half of this parabola. It's going to look like this. And I can reflect this point. Okay, my axis of symmetry is the y-axis in yellow. And I can just reflect it across, so I get a free point. I know that parabolas are symmetrical, so I can reflect that point, and I can just kind of reflect this point, and I can draw the other half of this parabola. It's going to look something like this. We're just sketching it. Okay, so that is the graph of y equals negative 4x squared. Okay, one thing you might want to know is, it opens downward. And it opens downward because this is a negative. So this negative right here tells us that when it's going to open up, it's going to open downward. Okay, moving on to the next one. Y equals 1/4 x squared. So this is going to be y equals 1/4 x squared. And I'm going to be a little more careful when I plug in some points here. I'm going to plug in 0 is fine. And I probably want to plug in, I'm going to be dividing these numbers by 4 or multiplying them by 1/4. So I want to probably pick increments of 4. So I'm going to pick 4 here, or just even numbers at least. And, well, actually, don't have to do that. I can pick 2, and then I can pick 4. So you'll see when we plug them in. So I plug in 0. 0 squared is 0. 0 times anything is 0. Plug in 2. 2 squared is 4. And then I multiply that by 1/4. So this is just going to be 1. And then when I plug in 4, 4 squared is 16. And 1/4 of that is going to be 4. So I have those points right there. And let's plot that. So I got 0, 0 again, over 2 up 1, and then over 4 up 4. Okay, so this is going to be much wider. And I can go over here and do the same thing, reflect it. So my axis of symmetry, this is 2 away from my axis, so I can go 2 away over here. This is going to be 4 away from my axis of symmetry, so I can go to negative 4 over here. And it's going to look like this. Okay, so I've got that. And I'll highlight that one in green. Okay, last one in purple, y equals x squared. So this is the simplest quadratic function. Just plug in 0, 1, and 2. And 0 squared is 0, 1 squared is 1, 2 squared is 4. You can do another one, 3 squared is 9. Keep going if you want to. So I'm going to plug in 0, and I get 0, plug in 1. 2 squared is going to be 4 right there. Get rid of this now. So 2 squared is going to be 4, and 3 squared is going to be 9. And I have this function right here. And I can also do the same thing on the other side. That's going to be 2 away, 3 away. And I just reflect those points. Okay, so this would be the purple function. And the other one, I think it got erased. This is going to be the green function right there. All right, so I've got that. And notice that when I plug in, if I were to plug in another number here, let's say I were to plug in 6. So 6 squared is going to be 36, and 1/4 of 36 would be 9. So I could keep going with all of these graphs also. So this would be 6, 9, make my graph a little bit wider. Okay, well that's where it is. So I can keep plugging in points, but we're just graphing this to get a general idea. So it says then we want to compare these graphs. Okay, and the widest graph would be the green graph. Okay, the narrowest graph would be the orange graph. Okay, so that's one way to compare them. We'll talk about another way in this next example here. Well, actually, we'll go back to this. So when I have y equals ax squared plus bx plus c, okay, my a function, or my a value, tells me a lot about this. So my a value tells me if it's going to open upward or downward. Okay? If a is positive, so if a is greater than 0, it's going to open upward. And if a is less than 0, it's going to open downward. So my a tells me that. And it also tells me how wide it is. Okay, the larger the absolute value of a, the more narrow the graph is going to get. Okay, in the next example of notes, we're going to use Desmos, and we can kind of use that to see how different numbers change how the graphs look. Okay, let's go to problem 5. Last problem here for notes. So an acorn drops from a tree branch 20 feet above the ground. The function is h equals negative 16t squared plus 20. Gives the height of the acorn after t seconds. What is the graph of the quadratic functions? And about what time does the acorn hit the ground? So remember we talked about negative 16t squared. You're going to see that a lot. That has to do with gravity. And then this plus 20 is the height. Okay, so the last term in your quadratic function, if it's related to height, is going to be the height that something starts at. So what I'm going to do is I want to know when it hits the ground. So when it hits the ground, the height is going to be 0. So I plug in 0 here, and I just leave t squared blank. All right, so I plug in 0 there. I want to make the height 0. From there, I'm going to subtract 20. I'm going to solve for t. Okay, just using algebra. So I have negative 20 equals negative 16t squared. And then I'm going to divide by negative 16. And I get t squared equals 20 over 16. Negative divided by negative is a positive. And I can reduce this by dividing them both by 4. So I get 5 over 4. Right, so then t squared equals 5 over 4, and I want to take the square root of this. So t equals the square root of 5 over 4. And if we type that into our calculator, pull up calculator here, it's going to be very close to 1. So the square root, hit the fraction button there, 5 over 4 is going to be 1.1 second, basically. Okay, so this is going to be 1.1 second. We can do a little squiggly line here, 1.1. Okay, what else can we do here? Well, we can kind of sketch a graph, just a very simple graph. It starts at 20 feet. This might be 1 second. 1.1 second might be right here. So it's going to hit the ground at 1.1 seconds. So this is the height, and this would be how many seconds. So after 1 second, if I just follow this graph, after 1 second, this thing might be at 19 feet. Okay, after half a second, might be up here at 8 feet, something like that. Remember, objects as they fall, they accelerate, so it goes faster, so it wouldn't be just half of it, it'd be 7 or 8 feet, something like that. Okay, what is the domain and range of this function? So the domain is all the possible x values. Okay, and the x values, and I'll highlight that in orange, the x values are right here. So this is all the possibilities. So the x values, as soon as this thing starts falling, would be considered 0 seconds. The x values stretch from 0 to 1.1. Okay, and includes 0 and 1.1. So we could write that as a compound inequality. So it goes from, it's in the air from 0 seconds to 1.1 second. And I guess it's not technically in the air at 0 seconds, so maybe it would be greater than 0 and less than 1.1. Okay, the range is all the possible y values. Okay, and the possible y values, I'll do that one in blue. Well, the acorn's at 20 feet, then it goes to 0 feet. So that's my y-axis. So this could be 0 to 20 feet. Okay, and it could include both of those. So 0 to 20 feet would be all of my possible y values. Okay, so that's a little bit more about domain and range. All right, so your homework. Let's scroll to day 2. So I think we're at page 37, something like that. Where was it there? Okay, right here. So your homework is, it's in Google Class, and I'll put it in School Loop also. You are going to do numbers 7 through 10. And this is 9-1 up here, practice. And then you're also going to do 14 through 18. So you got a couple more problems where you're graphing. And then you have a couple problems like we just did with the acorn, where you got to find out the value of t. All right, hope that helps. See you guys in a little bit.